At 12:40 p.m. Eastern Standard Time, December 11, 2022, the Orion spacecraft for the Artemis 1 mission splashed down in the Pacific Ocean after a 25.5-day mission to the Moon. Flight controllers and mission control at NASA's Johnson Space Center in Houston spent about 2 hours performing tests in open water to gather additional data about the spacecraft. Orion was then recovered by NASA's Landing and Recovery Team, U.S. Navy and Department of Defense partners aboard the USS Portland. Recovery personnel also spent time collecting detailed imagery of the spacecraft before beginning to pull the capsule into the USS Portland's well deck. The ship will soon begin its trip back to U.S. Naval Base San Diego, where engineers will remove Orion from the ship in preparation for transport back to Kennedy Space Center in Florida for post-flight analysis. Orion is expected to arrive to shore December 13. In this photo from December 15, 1965, the Gemini-VII spacecraft is seen from the Gemini-VI-A spacecraft during their rendezvous mission in space. The two spacecraft are approximately 43 feet apart. Astronauts Jim Lovell and Frank Borman launched on Gemini-VII on December 4, 1965, and eventually spent 2 weeks in orbit, the longest duration flight at that time. Just as Orion and the International Space Station are helping NASA learn how to go to Mars, the Gemini program defined and tested the skills NASA would need to go to the Moon in the 1960s and 1970s. Gemini had 4 main goals: to test an astronaut's ability to fly long-duration missions, to understand how spacecraft could rendezvous and dock in orbit around the Earth and the Moon, to perfect re-entry and landing methods, and to further understand the effects of longer spaceflights on astronauts. A SpaceX Falcon 9 rocket with the surface water and ocean topography spacecraft on board is seen as it rolls out to the pad, Tuesday, December 13, 2022, at Space Launch Complex 48 at Vandenberg Space Force Base in California. Jointly developed by NASA and Centre National d'Etudes Spatiales, with contributions from the Canadian Space Agency and the United Kingdom Space Agency, SWOT is the first satellite mission that will observe nearly all water on Earth's surface, measuring the height of water in the planet's lakes, rivers, reservoirs, and the ocean. Surface water and ocean topography is set to launch at 6:46 a.m. Eastern Standard Time on December 15, 2022. Against an inky black backdrop, the blue swirls of spiral galaxy NGC 6956 stand out radiantly. NGC 6956 is a barred spiral galaxy, a common type of spiral galaxy with a bar-shaped structure of stars in its center. This galaxy exists 214 million light-years away in the constellation Delphinus. Scientists used NASA's Hubble Space Telescope to image NGC 6956 to study its Cepheid variable stars, which are stars that brighten and dim at regular periods. Since the period of Cepheid variable stars is a function of their brightness, scientists can measure how bright these stars appear from Earth and compare it to their actual brightness to calculate their distance. As a result, these stars are extremely useful in determining the distance of cosmic objects, which is one of the hardest pieces of information to measure for extragalactic objects. This galaxy also contains a Type Ia supernova, which is the explosion of a white dwarf star that was gradually accreting matter from a companion star. Like Cepheid variable stars, the brightness of these types of supernovae and how fast they dim over time enables scientists to calculate their distance. Scientists can use the measurements gleaned from Cepheid variable stars and Type Ia supernovae to refine our understanding of the rate of expansion of the universe, also known as the Hubble constant. A portion of the open cluster NGC 6530 appears as a roiling wall of smoke studded with stars in this image from the Hubble Space Telescope. NGC 6530 is a collection of several thousand stars lying around 4,350 light-years from Earth in the constellation Sagittarius. The cluster is set within the larger Lagoon Nebula, a gigantic interstellar cloud of gas and dust. Hubble has previously imaged the Lagoon Nebula several times, including these images released in 2010 and 2011. It is the nebula that gives this image its distinctly smoky appearance. Clouds of interstellar gas and dust stretch from one side of the image to the other. Astronomers investigated NGC 6530 using Hubble's Advanced Camera for surveys and Wide-Field Planetary Camera 2. They scoured the region in the hope of finding new examples of proplyds, a particular class of illuminated protoplanetary disks surrounding newborn stars. The vast majority of known proplyds are found in only one region, the nearby Orion Nebula. This makes understanding their origin and lifetimes in other astronomical environments challenging. Hubble's ability to observe at near-infrared wavelengths, particularly with Wide Field Camera 3, have made it an indispensable tool for understanding starbirth and the origin of exoplanetary systems. The new James Webb Space Telescope's unprecedented observational capabilities at infrared wavelengths will complement Hubble observations by allowing astronomers to peer through the dusty envelopes around newly born stars and investigate the faintest, earliest stages of starbirth.